So the first thing that we are talking about for this unit is a probability distribution. So first of all, remember, a random variable is a variable whose values are determined by chance. A discrete probability distribution consists of the values a random variable can assume and the corresponding probabilities of the values. The probabilities are determined theoretically or by observation. So the important word to note here is discrete. What does discrete mean? Who remembers from chapter 1?
By itself?
No.
It can't be counted by ones.
Flip. Yep. It's countable is discrete. Okay. Continuous is your other one. Okay. So discrete means it's countable. So the number of people in this room, the number of people who forgot their calculator, the number of students in the school. So that is discrete, whereas continuous would be something like time, because it can be broken down further. Length, distance, okay? So know that for probability distributions, these are discrete values. So to make a probability distribution, you make a frequency distribution, and then you find the probability. So this is no different than what we've already done, okay? So you find it, and then you find the probabilities. If a graph is required, you place the outcomes on the x-axis and the probabilities on the y-axis, and then draw vertical bars. So it's a histogram for that, okay? So example 1, a company employs 25 salespeople. During a randomly selected week, 5 people made 2 sales, 11 people made 3 sales, 6 people made 4 sales, and 3 people made 5 sales. Construct a probability distribution for the number of sales employees made for the week. So the first thing we're going to do is make a table for sales and then the frequency. So I had 2 sales, 3 sales, 4 sales, and 5 sales. How many people had 2 sales? 5. How many people had 3 sales? 11, 4, and 5. 3. Then I'm going to find P of X, the probabilities. So I'm going to take the frequency and divide by the total. Write it as a decimal. Now I'm going to do a graph. So what's the highest probability I have? 0.44. So I'm going to go up to 0.5. So I need to have from 0 to 0.5. It's okay if they're not perfectly spaced, just make them close. My first one was 0.2. I find it easier to do my bars and then label my x-axis, but I don't care how you do it. The next one was 0.44, so it's about halfway. The next one was 0.24. And the last one was 0.12. And there's my histogram. Easy enough? Questions? Okay. You have 2 requirements for a probability distribution. The first is that the sum must equal 1. So think about it. If it's probabilities of all of the events, you have to have the probability that any of them can occur is 1, right? And then the probability must be between 0 and 1, so no negatives. So if I'm asking you on A through D, determine whether each distribution is a probability distribution. So you're basically going to add up your P of X and determine, does it equal 1 or not?
No.
So A is no, because sum does not equal 1 or sum is greater than 1. It didn't matter to me which way you say that, but I'm usually going to ask you to justify your answer or explain your reasoning, so you need to tell me why or why not. How about letter B? Yes. If I ask why or explain your reasoning, it's because the sum equals 1 and all probabilities are greater than or equal to 0. So you cannot have negative probabilities. How about letter C? Yes, and then again, same reasoning on my explanation for letter B. And then how about D?
No.
No, because why?
There's a negative.
No, and say P of X can't be negative. Okay, so the first thing we're going to do is we're going to find your total number. So someone find the total of my frequency column. I heard someone say it. 144. Okay. So what is the variable that we are looking at? So the variable we're looking at is the reasons for dropping a college course. Is it a random variable? There's no reason to think it's not, so yes.
You don't have to like give a reason.
Not on that one. All right. How many people were in the study? 144. And then 3 is complete the table. So how do I find the percentages? Frequency divided by 144. So go find your percentages. You can write it as a decimal or a percentage. I do not care.
How many decimal places?
4. Or let me rephrase that. It would be 2 numbers past the decimal. So yeah, 4 decimal numbers. 2 past the decimal for the percentage. I didn't finish that statement.
When it says percentage, do we have to write it as a percent?
I'm not going to care if you read it as a percent or a decimal. Okay, so from the information given, what's the probability a student will drop a class because of illness?
27.7.
27.78%. How about because of money? 4.86. How about because of change of major? I heard someone say it. 9.72. All right? Would you consider the information in the table to be a probability distribution? So it's not a probability distribution, but because we found percentages, they add up to 1, they're all positive, you could technically use the table of values as one. But it's not really a probability because it's not probability, it's not chance. Does that make sense? Yes, no, yes? It would not be considered one, but it does meet the qualifications if you chose to use those numbers as one, yeah.
So the answer would be no.
So no.
How do we know what it is not?
Because remember, probability distribution has to be a random, it's by chance. This is just a survey. It's not exactly by chance. By chance would be more like rolling dice, flipping a coin, that kind of thing. Are the categories mutually exclusive? So what does that mean? What does it mean to be mutually exclusive? The intersection must equal 0. They cannot occur at the same time. Based off of the table, are they mutually exclusive? Yes. There is nothing that occurs in more than one category. Are they independent?
Yes.
What is the definition of independent?
A and B equals A times B.
A and B equals A times B. Well, if A and B is 0, if you take the individual probabilities and multiply them, do you get 0? No, therefore not independent. Are they exhaustive? So is there like a definite end to the categories? According to the table. Does it keep going? No, it's exhaustive. So yes. Just these are some random questions that you might see in the future. I just kind of want to walk through what they mean. Not really stuff that I'm going to ask, but in case you see them on homeworks. Are the 2 requirements for a discrete probability distribution met? So this is what I was saying. While it's not a discrete probability distribution, if you look at the probabilities, do they add up to 1 and are they all positive? Yes, and so therefore technically they meet the requirements even though it isn't 1. And the reason why is because we sort of forced it to be 1 by finding all of the probabilities and the way that we did it, okay? All right, so the bulk of what you need to be able to do is this a probability distribution, yes or no? And you need to be able to tell me why it is or isn't. And then be able to create a probability distribution if I give you the information and go create a table, a graph from it. That's what you need from 5.1, okay? All right.